As convenient, you should have the notes in front of you, or will in a moment. You should have an equation sheet in front of you that's got the unit circle on it. That's going to be helpful. We're going to use both those things today. That's perfect. Thank you. At some point yesterday or today, I've been missing 2 people. All right. So, focus, gentlemen, focus. New formulas today. Double and half angle formulas. Double and half angle formulas. They are what they sound like. How do I find sine of 2 times x instead of sine of x? How do I find x divided by 2 if I have sine of x? These formulas came from the sum formulas. And I know that because sine of 2 theta is equal to sine of theta plus theta. And if you grab your equation sheet and you look at the sum formula for sine, you will notice that it's sine A cos B plus cos A sine B. Yes? But if A and B are both x, it's sine x cos x plus cos x sine x. And multiplication is commutative. That's a sine times a cos plus a sine times a cos, which is 2 times sine plus times cos. It is the sum formula that has been simplified for identical angles. You look like you don't believe me. Do you need to see it? Nodding. So, sum formula. Sine of A, yeah, times sine, cosine of B, A, B, plus cosine of A times cosine of B. What? No. You can if you want. I'm doing it because I was getting confused looks from a couple people in the back row. So I thought I'd show you. Oh, and nobody called me on my nonsense while I was talking. And you guys are looking at the equation sheet. I'm just going from memory. Help me out a little bit. Gabe, did I do that correctly? Gabe's nodding yes. That looks better. Okay. What do I mean when I say multiplication is commutative? Commutative. Multiplication is commutative. What is it?
Commutative, I think of like communication.
In other classes, yes. Very specific in math. It means that the order that I do the operation in doesn't matter. A times B equals B times A. 3 times 5 is 15. 5 times 3 is 15. Multiplication is commutative. I can reverse the order. Addition is commutative, right? 3 plus 5 is 8. 5 plus 3 is 8. The order doesn't matter. Division is not, right? 2 divided by 3 is different than 3 divided by 2. Subtraction is not. 2 minus 3 is negative. 3 minus 2 is positive. So addition and multiplication are commutative. They're buddies. Subtraction and division are not. But here we are doing addition and multiplication. In this second term, I can reverse these, and I haven't changed my answer. So this is sine theta times cos theta. I'm getting lazy with the parentheses. Plus sine theta times cos theta. What do you notice about those two terms? They're identical. Yeah, I have 2 of them. So this is just 2 times sine theta cos theta, which is exactly that first double angle formula. The other 2, the ones for cosine, the ones for tangent of 2 theta, come from the same way. I'm not going to do the algebra for you because I'm not going to ask you to derive it on a test. But if you don't believe me, we can do it after class or during your homework time. Yeah. So we're just taking 2 theta, splitting it up into theta plus theta, and using the formulas we already have, sum and difference. So let's go back, take a look at the other formulas. For tangent, we see that pattern of I see a fraction like we saw with the sum formula for tangent, 2 tan theta over 1 minus tan squared theta. That kind of looks like the sum formula for tangent. Cosine looks a little scary. So for the cosine formulas, this guy came from the sum formula for cosine. The sum formula for cosine is cos A cos B minus sine A sine B, which is where that's coming from. The question is, where did these two come from? Oh, come on. And the answer is they took this first expression and they used the Pythagorean identity. Don't say if. We started the semester with that. Pythagorean identity came from the Pythagorean theorem inside of the unit circle where the hypotenuse is 1. Sine squared plus cos squared equals 1. And they're using the Pythagorean identity to either replace cos squared or sine squared with the other guy. Why would we want to do that? Can anybody think of a reason? Hint, think back to your bell ringers. Why might we want to do that? Yeah, exactly like our bell ringer. We didn't have sine of x or sine of y. We only had the cosine function. So if I'm only given information about cosine theta, I want to choose the expression for cosine 2 theta that only has cosines in it. That's going to save me having to set up a right triangle and find missing sides. So for cosine, pick the one that involves the trig functions you have or know how to find. Yeah? We like choices. Okay, so scoochie up. Why we use them, and some examples. So 2 things. One of them is to find the exact value of a trig function for an angle not on the unit circle, or to find the exact value of a trig function when I know theta but I don't know 2 theta, like we did in the bell ringer, that kind of idea. The other is to simplify trig expressions. So evaluate and simplify, evaluate and simplify. Find numeric answers or rewrite an expression so that it's prettier and easier to solve. Yeah. So we're going to do some examples because I want to make sure we're comfortable with this. So first example, you see the direction says find the exact value of sine 2x, cos 2x, and tan 2x without solving for x. Without solving for x. I don't know what my angle is, but I want to know what sine of double that angle is. So, example 1. They give us sine of x is 1/8, and I want sine of 2x. Yeah? So, double angle formula. I'm going to look, what is sine 2x? And I know that it is 2 times cosine of x times sine of x. I have part of that. I know that that is equal to this. They told me in the word problem that sine of x is 1/8. What am I missing? Cosine of x. How do I find it? Triangle, very good. Right triangle. And the nice thing is when I go to do cosine of 2x and tangent of 2x, because it's all the same x, it's the same right triangle. Once I draw it, I don't have to redraw it for the other two parts of the problem. One triangle. So x sine is what over what? Opposite over hypotenuse. Very good. So opposite is 1. Hypotenuse is 8. I want to find this missing side here. So a squared plus 1 squared is 8 squared. A squared plus 1 is 64. A squared is 63. A is root 63. Check my math. Which can be simplified. And so we will. Root 63 is 9 times 7. Yeah, 63, 72, 81. Yeah, counting my nines, yeah. And square root of 9 is what? 3. So this is 3 root 7. Slightly less gross. Slightly. Perfect. So we're going to go back to our expression now that I have all three sides of the triangle and fill out cos of x, sine of x. So over here, we have 2, come on, pen. You can do it. 2, and then cosine is what over what? Very good. So adjacent, 3 square root 7 over hypotenuse, which is 8. And sine, we were told, was 1 over 8. So first thing I'm going to do is reduce to save myself some trouble, because 2 divides evenly into 8. So I know that that's going to become a 1, and that's going to become a 4. 2 goes into 8 4 times. And then I'm just going to multiply across the numerator, bless you, multiply across the denominator. So across the top, 1 times 3 root 7 times 1 is 3 root 7. Yes? This, on the bottom now, I have a 1 underneath the 1, a 4, and an 8. So 1 times 4 times 8 across the bottom. You don't double cancel. I took that 2, which is 2 over 1, right? It's a whole number. And I cross-canceled that 2 with that 8. I can't then cancel it again. It's no longer there. I canceled with the first fraction. I can't double cancel. What is 4 times 8? 32. And I know that 3 and 32 don't have anything in common. So that is sine of 2x. Happy face. Happy face. Next one. They didn't ask us just to do sine. They said cosine and tangent. So cosine of 2x. And we have to pick a formula. We have both sine and cos now, so I could use either. I'm lazy, and I don't like radicals. And I noticed that sine is an integer over integer, 1 over 8. I would prefer to use the formula for cos 2x that doesn't have a cosine in it. It's just sine. That way I don't have radicals floating around. So I'm going to grab the second formula. Cosine 2 theta is 1 minus 2 sine squared theta. So 1 minus 2 sine squared this case x instead of theta. So that's the middle formula from our double angle table, yeah? Middle formula. So 1 minus 2, and then I'm going to take my sign fraction and square it. And I'm going to erase my table here now that we know what it looks like. So 1 minus 2 and 1/8 squared. 1 times 1 is 1, 8 times 8 is 64. 2 and 64 can reduce to 1 and 32. Half of 64 is 32. Cross canceling. And then the question is, what is 1 minus 1 over 32? And the answer is 31 out of 32. I have a whole pie. Cut it into 32 slices. I take one of those slices. I now have 31 slices left. Where did the what? So remember that this is the same as 32 over 32. So it becomes that. And when you subtract fractions or add fractions, once the denominators match, combine the numerators. When in doubt, because I know that fraction math is not our strong suit, nobody likes them. If you get to this stage where you had 1 minus 2 times 1 over 64, type it in your calculator with parentheses around the fraction, and then do math frac. Press the math button, to frac, enter. And it will convert whatever that ugly decimal that you got from that statement is into a reduced fraction. Matter of fact, you can test it now. It should give you 31 over 32 as an answer. I will give you a second for those of you with calculators to check. Yes. So you have two options. So you can do this, and then without pressing enter, do math frac, and it'll give you the reduced fraction right away. Or you can press enter after you type the expression, and then it'll give you a decimal. And then do math frac, and it'll convert your answer over. So one or the other. Should give you the same result, which is hopefully 31 out of 32. Ethan's nodding. That's a good sign. I had my morning dose of caffeine. I am sort of alert today. And Marissa's nodding. It's also a good sign. Good. So even without knowing x, I know cosine of 2x is 31 over 32. What do you notice about those two answers? Yes, same denominator. Good. We expect that because sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. They should have the same hypotenuse because they're coming from the same triangle. If they had different denominators, I would be concerned. Sine and cos of the same angle should always have the same denominator. Good. We have one more left, and that is tangent. And here is the good news. Yes, I have a double angle formula for tangent, but I already know sine of that angle and cos of that angle, and I happen to remember that tangent is sine over cos. So I'm not going to grab the tangent double angle formula. I am just going to do sine of 2x over cos of 2x, because I am lazy. If you use the double angle formula for tangent, 2 times tan theta over 1 minus tan squared theta, you get the same answer. I am lazy, so if I have sine and cos, why not do it this way? So we're going to grab our previous answers. In the numerator, Sine is 3 root 7 divided by 32. The denominator is 31 divided by 32. When we divide fractions, we turn them into multiplication problems. Fraction times fraction. Which one do I flip? The bottom, the denominator. Very good. So numerator stays the same. Denominator flips. What happens to those 32s? They cancel. So tangent is 3 root 7 over 31. Numerator for sine over numerator for cosine, which is what I expect. That's what I should see. Okay, I'm going to do the next one faster, and then I'm going to have you try one in your small group. Deep breath. You're going to be okay. Before we move on to B, are we good with me erasing that tangent statement so I have room to write? I don't see anyone saying no. Okay. Give myself some room here. Okay. This is nothing compared to what I did in stats this morning. You should be happy. This is fine. All right. Cosine of x is -1/2. X is in quadrant 3. So I have to think about the signs on my answer here. Quadrant 1, I didn't care because everything's positive. 3, I have to think. So I want sine of 2x. We know that that is 2 times sine of x times cos of x. I know that I only have cosine, I don't have sine. So I'm going to draw a right triangle. Angle x. Cosine is adjacent over hypotenuse. I am ignoring the sign on the number, just looking at the absolute value, numerator, denominator. So 1/2 means 1 and 2. Adjacent and hypotenuse, because cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Yes, Gerardo. What? That was a problem before, and the problem said find sine, cos, and tan. That was what the direction said. That's why. Yeah. Because it's good practice. Yes. Oh, so the first time I wrote it down, I read it off your equation sheet. The second time I did it from memory. That's how I memorized it. Multiplication is commutative, so it doesn't matter. Good question, Luis. Yeah, no, good question. No. This is when I had to memorize it when I took trig pre-cal at Hartnell. This is what I memorized. And that the cosine and sine switch, but multiplication is commutative, so we don't care. All right, I know cos, I don't know sine. To know sine, I need to know what this missing side is. So we're going to do some side math over here. I'm going to scooch you over. So a squared plus 1 squared equals 2 squared. So a squared plus 1 equals 4. A squared equals 3. A is square root of 3. I think I did that correctly. See nodding. Perfect. So I know, I'm going to come back in here and erase. I know this is root 3. Which is convenient because that was one of the special triangles we saw earlier this semester. 1, 2, square root of 3. So now we can go back and fill this in. I get 2 times a sine fraction and a cos fraction. I know my cos fraction is going to be -1/2 because I was told it was -1/2. My sine fraction, opposite over hypotenuse, is going to be root 3 over 2. And I need to think about the sine. So on your unit circle, You're going to go down to quadrant 3. And in quadrant 3, are my y coordinates positive or negative? Negative. So my sign should also be for quadrant 3 negative, because x is in quadrant 3. So sine and cos should follow the signs for quadrant 3. Good. Negative times negative is a positive. Tangent in quadrant 3 is positive. That's happy. These 2's will cancel. We'll be left with a single 2 on bottom. And 1 times anything is itself. So this is root 3 over 2. You just came back. Brandy is back. Sarah is back. We agree? Nodding. Okay, good. Next one. Cos of 2x. I'm going to do a similar thing. This time cos is the one without any radicals. So I'm going to do 2 cos squared x minus 1. That's the third formula for cos 2x. And it's one that only has cosine, because cosine doesn't have any radicals in it. And I substitute. So I get 2 times cosine squared. Cosine is minus 1 over 2, minus 1. You can use any of them. All 3 of those expressions, after some simplification, will get you to the same answer. Yeah, I always pick, excuse me, if I have a choice, if one of those functions, sine or cos, has a radical and the other does not, I'm going to go with the one without a radical. Because I'm lazy, right? We all agree we don't like radicals if we don't have to. Again, you'll get to the same place either way. You just might have to do more simplification. Yeah. Okay, so negative 1/2 times negative 1/2 is 1/4. Positive. So this is 2 times 1/4 minus 1. The 2 and the 4 are going to reduce. I'm going to get a 1 and a 2. So this is 1/2 minus 1, which is negative 1/2. Yeah. And what do we notice about those denominators? They're the same. They should always be the same. If the angles are the same, sine and cos have the same denominator. Very good. So far, so good. Very good. Next step, we do tangent. See if I can, no, I can't. I'll do it down here. So tangent of 2x, I'm doing it the lazy way. That's sine of 2x over cos of 2x. I build my fraction. Sine was root 3 over 2. Cosine was negative 1 over 2. And I am going to save myself some trouble. I know when I flip the denominator, those halves are going to cancel, just like they did last time. I'm left with root 3 divided by negative 1. Sign will be positive or negative? Negative. Positive divided by negative is negative. Anything divided by 1 is itself, so root 3 divided by 1 is root 3. Yeah. Tangent of 2 theta is root 3. It was short. It is pretty. I didn't have to rationalize a denominator. I do have a thought-provoking question for you. We were told that the original angle x is in quadrant 3. based on the signs for sine and cos, sine is positive, cos is negative, which quadrant is the angle 2x sitting in? I have a vote for 4. Do I have other votes? And if it helps, cosine comes first. Cos is negative, sine is positive. That's 2. That's 2. That's to the left and then up. That puts us in quadrant 2. Yeah. So our original angle was in quadrant 3, but when I double it, I end up in quadrant 2. Yeah. Double and half angle formulas are going to put us in new quadrants because I'm either making it twice as big or I'm cutting it in half. Yeah. Good. Good. I am going to put 5 minutes on the clock. I want you to try C with your neighbors. It's good for you. So I'll give you about 5 minutes to tackle C. Yes, to do all 3. That's how you learn, all 3.
Okay.
Your squids are adorable. They are not becoming a distraction, are they?
No, this is just really confusing.
So, you know that tangent of x, single angle x, is negative 8. You want sine of 2x, cos of 2x, tan of 2x. I know these guys must be related because they're based on that same original angle. I have formulas for what tangent of double an angle looks like. So we grab our equation sheet. And we go to the double and half angle formulas. Double angle for tangent of 2 theta, it's 2 times tan theta over 1 minus tan squared theta. And I have tan theta. In this case, tan x. I know it's negative 8. So I would come in here, and everywhere I saw a theta, I'd plug in, or a tan theta rather, I'd plug in a negative 8. So 2 times negative 8 minus 1 times negative 8 squared.
Is that like for
That'd be for the last one.
tan?
That'd be for tan. For sine, I'd grab the sine function. Sine is 2 sine theta cos theta. Well, I don't have sine theta cos theta. I have tan.
Every theta would be negative 8, right?
No. Tangent of theta would be negative 8, not theta itself. So that's why we were drawing right triangles. I don't know what the angle is, but I know what the ratio that goes with that angle is. Same situation here. So you're going to have to draw a right triangle.
To find out what sine of theta is.
Correct. Good. And cosine of theta. Good. Good. What we're doing is we're bypassing solving for the angle by finding the missing sides and setting up new ratios. Yeah. So, yeah. Sine and tangent, we don't get choices, right? Draw your right triangle. About. So remember that the original function gives me an idea of the side lengths. So you need to draw a right triangle. Angle x. And tangent is opposite over adjacent. So negative 8 over 1. And technically we just do 8 over 1. Didn't know what the sign. Yeah, good. And then you can find your hypotenuse. And then you can find sine and cos. Yeah. Follow the model, right? Draw the right triangle to find the missing sides for the angle x. Use the double angle formulas to set up sine, cos, tan for 2x.
I want to go to the restroom, but it's full apparently.
I will make you a pass. Draw your right triangle. Follow the example. Melanie's back. Okay, I'm gonna start with Cecilia, and then you guys will be next. Yes.
For this one, would this be E will go to opposite, right?
Yes, and you can drop the sign. You can just treat it as 8 instead of -8 for the right triangle. I don't really care about signs.
And then
But it's, if I need to write it as a fraction, perfect, over 1. So opposite is 8, adjacent is 1.
okay.
Good.
Okay.
Missing side's hypotenuse. You know how to find that?
Yeah.
Yes. Good. Okay.
A month to lock in.
Okay. So
Am I
this,
on the right track?
you're right. And then tangent is opposite over adjacent. And this is technically 8 over
One.
1. So
Okay.
opposite is 8, adjacent is 1. Find the
Okay,
hypotenuse. You got it. You got it.
I don't understand this.
I am a little concerned that we're not even on the right side because we're over here. And we just did those two together. And you are working with Gerardo to try C.
Thank you.
I don't
So
understand.
you drew, first, I have tangent of x is -8 or 8 over 1. I need a right triangle so I can find the missing hypotenuse. All right, you're going to help me with this. Oops, that is not what I meant to do. Try that again. All right, I need a volunteer. First thing I should do, write the equation. Okay, so we'll start with sine 2x. Do it in the order they asked. Sine 2x is 2 times sine of x times cos of x, or cos of x times sine of x, whichever you prefer. I don't have sine or cos. I have tan. Somebody other than Luis, what do I do next? Yes, draw my right triangle. Draw my right triangle. Very good. Ooh, that came out messy. So angle x, tangent, ignoring the sine is 8. Yes, Gerardo? You sure? Okay. Tangent is opposite over adjacent, and that's basically 8 over 1. So opposite side is 8, adjacent side is 1. I need my hypotenuse. I'm ignoring sine for the moment, just the length of the side. Oh, no. So 1 squared plus 8 squared equals c squared. 1 plus 64 equals c squared. C squared is 65. So c is square root of 65. Yeah, good. So square root 65. Happy face. I see some nodding. 65 is not divisible by any perfect squares. I don't think we can reduce that. Yeah? I'm going to assume yes. Nobody's arguing with me. 2 times sine fraction times cos fraction, keeping in mind that I am in quadrant 4. Quadrant 4. So you're going to grab, before I even do my fractions, you're going to grab your unit circle. If I am in quadrant 4, is my x-coordinate positive or negative? Positive. So cosine is going to be positive. Is my y-coordinate positive or negative? Sine is going to be negative. Because coordinates on the unit circle are cosine comma sine. Cosine follows the sign on x. Sine follows the sign on y. If I look at a point on the unit circle. I go to the right triangle to set up those ratios. So sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Do we agree? Huh, that is a good thing. First, we address the sign. I have a positive number times a negative number times a positive. What is the sign on my answer? Negative. Very good. So this is negative. And then 2 times 8 times 1 is 16. And on the bottom, Root 65 times itself. 65, yeah. And that, I don't think, can be reduced. 16 is just 2 to the 4th, I believe. And 65 is a whole bunch of 5s and I think a 3 somewhere in there. They don't have any common factors. Good. Happy face. Yes. Are you on the struggle bus today? Yeah, that's okay. I have those days too. Cosine of 2x. We need to pick one of those 3. Does anybody have a preference? No, I can't get away from the radicals this time. So I'm going to go with the middle one, 1 minus 2 sine squared theta for funsies. 1 minus 2 sine squared of x. So 1 minus 2, and then whatever my sine fraction is squared, and I have my sine fraction from the last problem. Sine is negative 8 over root 65. Okay. In the numerator, I have a 2 times a negative 8 squared. So negative 8 times negative 8, positive 64. Positive 64 times negative 2. $128, I think, yeah. So negative 128 over, and then root 65 squared is 65, yeah. Which is negative 63 over 65 when I check on my calculator. If you do not believe me, you may check on your calculator as well. Pretty sure I did that correctly. One becomes 65 over 65. And then numerator, 65 minus 128 is negative 63. Yeah. Good. Last one. Now that I have sine of 2x and cosine of 2x, I can find tangent of 2x. My sine fraction was the first answer we boxed, negative 16 over 65. Cosine is the second answer I boxed, negative 63 over 65. What happens to those negative signs? They cancel. What happens to those over 65s? They cancel, and I get 16 over 63. A ratio of the numerators for sine and cosine, which is what I expect for tangent. Bonus question before I give you a 5-minute break. Which quadrant does angle 2x sit in based on sine and cos? Which quadrant is 2x in? Sine is negative, cos is negative. Where am I? 3. Yeah, our original angle x is in quadrant 4, When I double it, because it was already big, we end all the way back up around in quadrant 3. Yeah. Good. Very good. I'm going to pop, let's say, 5 minutes on the clock for you to stand up, stretch, take a break, and then we'll do the backside. And I will do the opposite and sit down because I am old and sore. That's fair. We used to do that with the racers instead of squishies, but yeah. I don't know. I don't get enough crunch from the things inside the squid. Doesn't do anything for me. This makes me happier. This gives me resistance. Yeah. Something to take my stress out on. I like your apple tree or cherry tree. It's very cute. Is he your table protector? Yeah.
What is it? Oh. Cute.
The blush just that needed the blush. Yes, Bruno.
You know what I hate?
What?
Postvital cough. You know what that is?
The what?
After you get cold or flu.
Oh, and then you're hacking and coughing for days?
Yeah, and it's not even a contagion or anything. You just cough for no reason.
Your throat's all irritated from all that post-nasal drip? Yeah. The joy of having nurses for parents. How are we doing, Julie? Good. We're hanging in there. Yeah. Ish. Think happy thoughts. You have 1 quarter of high school left.
That's still 1 whole quarter.
Which is like, what, 8 weeks? 9 weeks? But the last week doesn't count for you, so that's 9. No, they had a week too. It was they had theirs is a little different in that they had their senior finals and then a day and then went to Disneyland. And then the following week was their week off. And this year Disneyland got moved earlier, and that's the weird part. Yeah.
Tomorrow Purdy went to the Monterey Fairgrounds.
Who? What? Huh? What?
Tomorrow Purdy went to the Monterey Fairgrounds.
Oh, nice. I've heard a couple people are. I know FFA is going. Are you going with FFA or for a different reason?
For
Gov. Okay.
What is it? Econ.
Econ.
Yeah.
Who's your econ teacher?
Chelly.
So Chelly's taking my seniors away. Okay.
Except there was only like 125 seats, so not everyone.
That's a lot, because I only have 87 stats kids, and a lot of them have Uccelli.
There's 400 seniors, so yeah. That's
Yeah. I'm glad I'm not doing anything important in stats tomorrow.
That's good. They're coming back at 3 p.m.
You may sharpen your pencil before we move on to the next thing. While we are waiting for pencils to sharpen, flip your page over. We're going to start on the back side. You're also probably going to want your unit circle handy. So when you look at the backside looks very similar. We have a table full of new formulas. These are half-angle formulas, meaning if I know cosine of 30 degrees, I can find the exact value for cosine of 15 by using the half-angle formula. Because 15 is not on my unit circle, but 30 is, and so I can make the switch. So half-angle formulas are great at helping us find exact values of things that are not on the unit circle themselves, but they're double their buddy is. Also helpful for sometimes simplifying. You will notice that the functions that are listed here all involve square roots, which is the exact opposite of what we saw with the double angle formulas. All of the double angle formulas had a trig function squared, sine squared, cos squared, tan squared. Now we have things being square root. So if I double inside a trig function, I'm ending up squaring something outside. If I cut something in half inside a trig function, I'm taking the square root outside. So that's an interesting relationship that we should keep in our brains. Similar idea, except now our choices come down to tan. And there's an extra choice because we know tangent. Come on, Ben. We can do this. Tangent of alpha over 2 would just be sine of alpha over 2 divided by cosine of alpha over 2. So if I already know sine and cosine, I can just do sine divided by cos, which is what we were doing on the back side with the double angle formulas. I have choices for tangent that I don't for the others. Because this is most common for pulling values off the unit circle, that's where we're going to start. We're going to do some examples of how to use half-angle formulas to find the answers to trig functions where the angle is not on the unit circle itself. So I'm going to scoot you up. We're going to do some examples together. We're going to start with A. It says, find the exact value using the half-angle formula. And the angle I'm given is sine of pi over 8. Is pi over 8 on the unit circle? No, but I know that pi over 8 is half of pi over 4. This is this. You might be asking yourself, why is that useful? Well, it's useful because the half-angle formulas will allow me to rewrite sine of pi over 8 in terms of sine of pi over 4, which I can then go look up on the unit circle. So that's the plan. That's the plan. So first thing I'm going to do is grab my half-angle formula. So for sine, it says sine of alpha over 2, pi over 4 over 2, is equal to plus or minus, and then we get a square root with a fraction. It says 1 minus cosine of theta over 2. So 1 minus cosine of pi over 4 over 2. All square rooted. Top and bottom. Whole fractions under the square root. A note before we pull cosine of pi over 4 off the unit circle. And that note is that you see a plus or minus. And plus or minus does not mean that we get two answers. What it means is you are going to choose the appropriate sign based on where the original angle was. So pi over 8, which we know is smaller than pi over 4 but still positive. Which quadrant does pi over 8 sit in? 1, quadrant 1. In quadrant 1, sign is positive. So I'm going to scribble that out. I know that this should be positive because of the quadrant I'm sitting in. Pi over 8 is in quadrant 1. Sine and cosine are both positive. Yeah, good. Now, unit circle and simplify. Unit circle, simplify. So cosine of pi over 4. On the unit circle, who can tell me what cosine of pi over 4 is? Square root of 2 over 2, yeah. And if you were me, you're making a frowny face. I now have 2 things I don't like. Yes, Marissa? Ah, because the whole point of the half angle formula is to turn it into a whole angle. Yeah. Yeah. Why did you sit in the back if you know you're going to say, wait, what, every 5 minutes? Why didn't you sit up here with me, friend? It could be worse. My stats class is so full. I got kids right up here. So, yes, we're just pulling from the formula. No, that's okay. You're okay. I'm glad you're on top of it and you're asking questions when you need to. So, 2 conundrums. I have a square root under a square root, and I have a fraction inside of a fraction. I can only fix one of those. With half angle formulas, you need to get comfortable with seeing square roots underneath square roots. Most of your answers will have this. That is correct. That is what it's supposed to look like. What? Huh? If we wanted a decimal answer, I would just put this in the calculator. The point of this is exact answers. So no, I don't want to put it in a calculator. I want to make it as pretty as humanly possible and then leave it. And pretty as humanly possible means I'm going to have a square root under a square root. What I do want to get rid of is the fraction inside of a fraction. That's fixable. I know if I have a tiny fraction inside of a big fraction, if I multiply the top and the bottom by the denominator of the tiny fraction, it's going to get rid of the tiny fraction. Yes, Gerardo? No, because that guy's not over 2. It is the whole number 1 minus a tiny fraction, root 2 over 2, all over 2. So it's that, because that fraction came from the cosine. Yeah, no, that was a good question. This, when we do it, we're going to have to distribute because I'm distributing to a binomial, but it is going to fix that fraction issue. So top and bottom by the denominator of the tiny fraction, we'll get rid of the tiny fraction. In the numerator, we're going to distribute. This is going to go to the 1. This is going to go to the fraction. 1 times 2 is 2 minus, and then root 2 over 2 times 2. Just root 2. Yeah. 1/2 times 2. The 1/2 and the 2 cancel. I'm just going to be left with that root 2 hanging out on top. On the bottom, 2 times 2 is 4. There is one more conundrum that is easily fixable. We don't like to have radicals in denominators. Having the whole fraction under a square root is kind of icky. But 4 is a perfect square. What is the square root of 4? 2. So I can rewrite this as square root of 2 minus root 2 all over 2. If that hurts your brain, you are not the first person to say that. It doesn't look pretty, but that is the exact answer. Jala speaking. Hi. I'll send her on down. Bye. Brandy, that's for you. We will miss you desperately. Have a wonderful day. Julie came back. Okay. Try another one. Practice makes perfect. Next one, cosine of 7 pi over 8. The first question, is 7 pi over 8 in the unit circle? No. 7 pi over 8 is not in the unit circle. So I am going to write it as 7 pi over 4 over 2. You saw that in the last one. What do you notice is happening with the denominator? It ends up the same if I were to undo the process. But when I split it up, what am I splitting it up into? I went from 8 to 4. I went from 8 to 4. In the next one, I'm going to go from 12 to 6. Yeah, we're cutting that denominator in half and pulling that half out into the bottom. Yes. For half angle formulas, it will always be like that. So we're going to pull the formula for the half angle formula for cosine. And I know it looks exactly like sine, except the operation inside changes. 1 plus cosine 7 pi over 4 all over 2. And before I move on, I need to think about the sign in front of the radical. So we go back to the original angle, just like we did last time, and we ask ourselves, come on, TV, I'm so tired. What quadrant is it in? I'm getting a vote for 4. And that's halfway between, I think it's in quadrant 2. Because that 7 pi over 4 is halfway between 6 pi over 8 and 8 pi over 8. 8 pi over 8. It's not pi over 4, 7 pi over 8. The original angle. Original angle. 7 pi over 8 is halfway between 6 pi and 7 pi over, or 8 pi over 8. 6 pi over 8 is 3 pi over 4. 8 pi over 8 is pi. So if I look at my unit circle, that angle here is 3 pi over 4, which is 6 pi over 8. I'm allowed to multiply top and bottom by 2, yeah? This angle here is pi, which is the same thing as 8 pi over 8. The angle I'm looking at is halfway between them. 7 pi over 8. Which quadrant am I in? 2. This isn't quadrant 2. What do you mean, where did I get an angle all the way from quadrant 4? I don't care about 7 pi over 4. I care about the original. I care about the original. I care about the original. We'll worry about 7 pi over 4 later. I want 7 pi over 8. Where is 7 pi over 8? Second quadrant. I expect that if you are in a college math class, you know how to count by eighths. 1/8, 2/8 is 1/4, 3/8, 4/8 is 1/2, 5/8, 6/8 is 3/4. I am choking on my own spit. That is very sad. If you are having difficulty estimating where 7 pi over 8 is, plug it into your calculator and get a decimal, because you know pi is 3.14. If it's between 0 and 3.14, it's somewhere up here. Yeah? So calculator converting the pi's to decimals is fine. Ideally, as college mathematicians, we can work with fractions. I'm going to erase my picture. And I have a question for you. In quadrant 2, is cosine positive or negative? negative. So I should have a minus sign out in front because I know my answer would be negative, should be negative. Okay, we go to our unit circle. Minus radical 1 minus, and then I need to know what cosine of 7 pi over 4 is. And we know it's in quadrant 4. Square root 2 over 2. Yeah. Well, that's nice. We already know what that's going to look like. We're going to multiply top and bottom by 2 to get rid of the tiny fraction. I know 2 times 4 is 4, and the square root of 4 is 2. So this is going to look a lot like what I saw the last time. Negative 2 plus root 2 all under a root over 2. It is, but what's the square root of 4? 2. If you can pull the bottom out of the radical, you should. If the bottom's not a radical, you can leave the whole thing under the square root. You don't have to like multiply by the radical on bottom and then make the top messier. That's silly. But if you can simplify the bottom, do it. Last one. We are almost done. One more. I want you to try it on your own following the pattern we just did. I'm going to give you about 5 minutes. Tangent of negative 3 pi over 12. We talked about the pattern. We know what the new denominator is going to be. I'll give you 5 minutes. So first step is here to here. And the pattern is going to be the same. It's going to be negative 3 pi over, and then half of 12 is what? 6 all over 2. And then tan in front. Yeah, good. And then you're going to equals, and you're going to come up here, and you're going to pick any one of, not that one because we haven't calculated sine and cosine yet, but any one of these 3. Whichever one you think is easiest. Aubrey, as soon as one of the 2 that's out gets back, you can go.
So since this one's all negative, like I got this and I would multiply it by 2. Or how was it?
So for now, I don't even need the unit circle. For now, I'm going to follow the pattern for the last 2, which is notice when I create tiny fraction over 2, the tiny fraction has the same numerator, negative 3 pi, but half the denominator.
Okay,
So what is that going to be?
6.
Yeah,
So what is the negative, right?
would. Yeah, good.
Okay. 3 pi.
And then when you use one of these 3 here, notice you're going to be pulling from the numerator, negative 3 pi over 6. And first, we should figure out where negative 3 pi over 6 is. Negative 3 pi over 6. What's 3 over 6?
3 over 6.
It's going to reduce. What's that going to reduce to?
1/3.
3 goes into 6 how many times?
2.
2, 1/2.
Okay.
This is just negative pi over 2. I start here. I know pi over 2 is half or a quarter of the unit circle, so negative would just be down
So
here.
do I write this number? Or
We don't write this number, but when you're going to use, I scooch back up, one of these formulas, and you go to pull sine and cosine for that angle,
I would use
it's
that one.
those values.
Okay.
Yeah.
Is there a specific one I have to
Nope.
use? Or
Any 3 of them will work.
which one do you say is easiest?
Because I'm down on an axis, doesn't matter, because I've only got zeros and ones. I would prefer one that doesn't have a square root over it if I can choose. So either one of those will probably be easier. What's up, Cecilia? Ooh, yes, but be careful. Negative, negative. And then when you wrote the formula, I don't know where you pulled the formula, but that is not one of those formulas here.
Okay.
So at that stage, copy one of the formulas from the box down and then start filling it in. Yeah. Yes. Oh, perfect. Okay, so notice that fraction is reducible. What does that reduce to? 1/2. And I know that 1/2 is a quarter of the circle and it's negative, so it's down here. There's your sine and cosine. Yeah.
Mr. Joel, if I'm lost.
Oh, this is perfect, but don't forget the minus sign. So it's negative. So this is perfect. That x is negative 3 pi over 6.
Yes.
That's
And
reducible.
Well, I'm looking like you said, because it would be like 3 pi over 4, right? And so I'm trying to look for 3 pi like
Over
where
6,
3
and
pi
you're not going to see. Oh, where that is?
Where that would be, because you said to pay attention to
Oh,
this one.
reduce it. How many times does 3 go into 12?
4.
4.
So 3 pi over 4?
So no, because the 3 canceled. It's
Oh,
just
so the
negative
3
pi
pi-
over 4.
What?
Negative pi over 4.
Oh, negative.
Because the negative, and then the 3 cancels with the 12, I get 1 over 4. So negative pi over 4. That's start at here, and instead of going up pi over 4, go down pi over 4.
So over here?
4. There. That's the original angle. You look at the sign on your answer. Tangent would be... Yeah, tan would be negative down there, because sine and cosine have different signs. Yes, but you're bypassing the... Yes, but you're bypassing the work. But yes, Gerardo, you have the right idea, yes. Gerardo has found the shortcut. We will talk about the shortcut in a minute. We're going to do it the long way first. There is. You just found it. Ellie still has not come back. Okay. You did. It's okay. I'll bring it back in a minute. All right. So we know the pattern. Yes. I saw in lots of people's papers tangent of negative 3 pi over what? 6. Very good. Half of 12 over 2. Well, I want to know the sign on tangent if I'm using a square root formula. Notice that for the tangent, I have 3 choices. I have square root 1 minus cos over 1 plus cos. And then I have 2 fractions that don't have square roots. I don't have to manually figure out the sign if I use the guys without the square roots. The signs will work themselves out appropriately based on sine and cos. So my instinct is if I don't have to, why would I introduce a square root? So I'm going to use one of the fractions that doesn't have a square root. Does somebody have a preference for sine on top or 1 minus cos on top? 1 minus cos. So Marissa did 1 minus cosine of negative 3 pi over 6 all over sine of negative 3 pi over 6. Good. And what is negative 3 pi over 6? Negative pi over 2. Yeah, this is 1 minus cosine of negative pi over 2 over sine of negative pi over 2, which means we're sitting on an axis. Half pi's are the axes. It's negative pi over 2, so I'm down between quadrants 3 and 4. So in the numerator, cosine is the x-coordinate. What is the x-coordinate at negative pi over 2? 0. 1 minus 0. In the denominator, what is the y-coordinate for negative pi over 2? Negative 1. So I have 1 minus 0, positive 1, divided by negative 1, which is negative 1. Yay! You can get that another way. And I think Gerardo had started to pick up on it, and then I interrupted and he didn't carry it through. But Gerardo noticed if you reduce at the beginning, that angle is also on the unit circle. How many times does 3 go into 12? 4 times. That's just negative pi over 4. And you end up with negative root 2 over 2 divided by positive root 2 over 2, which is negative 1. Yeah. Yeah. You did. Yeah. So you are going to notice for a lot of this unit and the next unit, it's very formula heavy. In that I'm going to see patterns, I'm going to recognize it as double or half angle or a sum or a difference, and I'm just going to grab the formula off the equation sheet and substitute values in. That's why I have this pre-printed, right? I don't expect you to memorize any of the equations from your notes. I do expect you to know how to use them. I think that this is posted in Canvas. So if you want to use this while you're doing your homework, you want to practice with it so that on test day you know where to find everything, this is up on Canvas. It should be under the very first module, important course paperwork. Yeah? Okay. Questions on that second half of notes? Okay. You've got about 10 minutes of homework time. If you have questions, let me know. And when I see you on Friday, we'll do a little small group activity together to practice. Yeah.